Good morning, my 8th grade students. So I could tell we were struggling with solving by substitution last time, so we're going to be talking about it a little more today. Remember, whenever you are solving by substitution, actually, whenever you're solving for a system of equations, period, remember, write this part down. When solving, you want one x value and one y value. In the end, that's exactly what you want. You want the x value and the y value where two lines would theoretically cross each other on a graph. The point in doing substitution is so you don't have to graph them to figure it out. You can figure it out just by looking at the numbers. So when we use the substitution method, we find the solution by basically rewriting one equation and then substituting it into the other. Alright, so we're going to say, let's say we have these two equations right here. Let's say we've got four x plus y equals 7. And 3x plus 2y equals 9. Alright, so we're going to have step 1 is technically optional. But it helps. Step 1, number your equations. So I'm going to call this guy right here number 1, and I'm going to call this green one at the bottom number 2. Now, step 2, or potentially step 1 if you chose to skip the optional step 1. Step 2. Isolate your smallest variable. What I mean by smallest variable is the one with the smallest coefficient, meaning the smallest number in front of it. So let's see, I've got a 3x and a 2y and a 4x and just a regular y. Well, just that regular y means that there's secretly a 1 multiplying the y. So given that my other ones have a 2, a 3, and a 4 in front of them, that y is my smallest variable. So now I can rewrite that as I can subtract 4x from both sides of it. And then I can rewrite it as y equals negative 4x plus 7. Now, step 3. Substitute it. Basically means another way you can write that, you don't have to write it twice. This is just another way to think about it if it helps you. Another way to think about it is replace the same variable in the second equation. So now I'm going to say I turn that 4x plus 7 into, you see how up here I had 3x plus 2y equals 9? Well, now that's going to become 3x plus 2 times whatever it is that y equals. So in this case, that's going to be 2 plus 2 times negative 4x plus 7. And it's still going to equal 9. Now we're going to say step 4. Solve for first variable. So in this case, because now I have nothing but x's in this one, I'm going to solve for x. All right, now to begin that process, I've got 3x 2 times negative 4x is negative 8, so 3x minus 8x 2 times 7 is 14, so that's plus 14 equals 9. And 3x minus 8x, that's negative 5x. Equals 9. Subtract 14 from both sides. That gives us negative 5x equals negative 5. Again, I'm just treating this like I'm just solving for x because for the moment that's what I'm doing. Now I'm going to divide by negative 5 on both sides and I'll get the first half of my answer. I'll get x equals 1. Now, step 5. Substitute the found variable into one of your original equations to solve for the other variable. Now in this case, I found x. I'm going to plug that x value into one of these two original equations to find y. I think this blue one, number 1, looks a little bit easier, so I'm going to plug it into that one. Or better yet, I'll plug it into this other version of my original one. No, I'm going to do it the original blue one, the one that's labeled number 1. Excuse me. So that will give me 4 times 1 plus y equals, let's see, what would that equal? 7. So let's see, 4 times 1 is just 4 plus y equals 7. And now subtract 4 from both sides. And we'll get y equals 3. And now I'm probably done. I can technically say, alright, I found x is 1, y is 3. If I was to graph both of these out, I would see that they come together at point 1, 3. And officially, that's our final answer. Unofficially, if you want to be super careful, substitute both the x and y values that you found and make sure that they come out right. Like make sure that 3 times 1, because we said x was 1, plus 2 times 3, because we said y was 3, actually is 9. And let's see, 3 times 1 is 3, 2 times 3 is 6, 3 plus 6 is 9, and 4 times 1 is 4, plus just 3, that would be 7 equals 7. Oh hey, these are right. I'm going to give you one more example. If you feel comfortable, don't worry about writing this one down. All right, so I've got, for my second example here, ex2 I've got negative 2x plus 6y equals 1. And for my second equation in this system of equations, I've got x minus 4y equals 2. I'm going to label this one number 1, this one number 2. Now let's see. Which one is going to be easiest to isolate? I think it's pretty clearly x on this one. So I'm going to say, in a way, sort of cross this out and rewrite it as x equals 4y plus 2. And now I'm going to substitute this into that one. So now I've got negative 2 times whatever x equals, so that's 4y plus 2, plus 6y equals 1. Alright, so that gives me negative 8y minus 4 plus 6y equals 1. I can combine like terms here to say negative 8y plus 6y is negative 2y. Minus 4 equals 1. Add 4 to both sides. And then I'll get negative 2y equals 5. Divide both sides by negative 2. And I'll get y equals negative 5 over 2. This is probably more complicated than anything I'll give you on the test when we have it. All right, now which one do I want? Now which one do I want to substitute back into? X minus 4y equals 2 or negative 2x plus 6y equals 1? I think the second one looks a little simpler. So I'm going to say x minus 4 times what y equals, negative 5 over 2, equals 2. Then I'll get 4 times negative 5 over 2 comes out to, let's see, 10. So that's x plus 10 equals 2, subtracting 10. And we'll get x equals negative 8. So my final answer for this one is, because I said x was negative 8, I solved for x second on this one, negative 8 and negative 5 over 2. Again, this second example is the most complicated you're going to see in this module. Thank you.